In this example, we're going to produce a type of diagram called a relative frequency histogram. This is not a common type of histogram, but it does have the interesting feature that the total area of all the bars is 1. It may not seem obvious to you at this stage why this is an interesting feature. However, this may become apparent when we deal with probability distributions later in the course. To get to relative frequency density, we need the class width and the relative frequency. Class width we're aware of. 5 to 15 is 10, 15 to 25 is also 10, 25 to 30 is 5, 30 to 35 is 5, 35 to 45 is 10, and finally 45 to 60 is 15. If we now total the frequency column to work out how many pieces of data we have, we find we have 120 pieces of data. To work out relative frequency, we divide each frequency by the total number of pieces of data. The relative frequency, therefore, is a measure of how frequently each class occurs compared to the total. So for this first class with a frequency of 20 and a total number of pieces of data of 120, we do 20 divided by 120, and this gives us 0.16 recurring. 35 divided by 120 is 0.2916 recurring. 44 divided by 120 is 0.36 recurring. 13 divided by 120 is 0.1083 recurring. 6 divided by 120 is 0.05, and 2 divided by 120 is 0.016 recurring. The relative frequency column must add to 1. To understand this, it might be better to think in fractions for a moment. The first class is 20 divided by 120, or 20 over 120. The second class would be 35 over 120, and so on. But 120 is the sum of all the numbers in the frequency column. Therefore, if we add them, we must end up with 120 over 120, which is 1. We now proceed to work out the relative frequency density, which is the relative frequency divided by the class width. This will be 0.016 recurring, then 0.02916 recurring. 0.36 recurring divided by 5 is 0.073 recurring. This divided by 5 is 0.0216 recurring. This is going to be 0.005. And finally, this one divided by 15 is 0.001 recurring. Now to plot the graph, relative frequency density goes on the vertical axis. so time goes on the horizontal axis. One large square represents 10 units of time. And on the vertical axis, we'll take one large square to be 0.01. We now need to draw the bars onto the diagram. Between 5 and 15, we have 0.016 recurring. Between 15 and 25, 0.02916 recurring. Between 25 and 30, 0.073 recurring. Between 30 and 35, 0.0216 recurring. Between 35 and 45, 0.005. And finally, from 45 to 60, 0.001 recurring.